please understand that there is some confusion amongst some of the participants. They do not understand what is P. P means the level of significance. Whether you have t-test or you have F value or you have chi-square or you have correlation, the level of significance can be 0.05 and 0.01. So it does not matter. So here you have not to compare so you have not to see that everywhere P value is same. P value has to be because it is the level of significance. Anyway, so we come to the another one in non-parametric and then Cochran's Q. And the assumptions are one of the assumption is there must be one criterion or dependent variable with two mutually exclusive group. Mutually two exclusive groups or levels. For example, say perceived safety. If perceived safety is your variable, then you can have the two groups as the safe and unsafe. If it is exam performance, then the two groups are pass and fail. If another variable is preferred choice of serial, the serial brand, then the two can be brand A and brand B. Another can be feeling seasickness. Here I am giving you different variables, names, which may have the two levels or which may be categorized into two groups. So feeling seasickness. Here the two groups are yes or no. You are feeling sickness, yes, or you're not feeling sickness, no. Another can be use of safety equipment. And use of safety equipment will be uses safety helmet, and does not use safety helmet. Another can be skin cream effectiveness. The two groups are rash and no rash. So like this, you can have as many variables with two levels or two groups. So this is what you must have. The another assumption is that there must be one variable that consists of three or more categorical related groups. My dear friend, when I say related groups, that means you have only one group. The same group undergoes this treatment, and the same group undergoes another treatment, and the same group undergoes another treatment. So when I say the related groups, it is the same subjects. And the data are either on ordinal scale or nominal scale. Because if you have that data on the ordinal scale, you can convert it into the nominal scale. So the ordinal scale data are something like this. For example, Likert scale. Likert scale, you may have the strongly agree, undecided, disagree, and strongly disagree. It may be 5 point, it may be 7 point, it does not matter. You can have as much as you like. Another is the physical activity level. It may be sedentary, another can be low, another can be moderate, and another can be high. So you have the 4 levels here. Another can be customer. You have customers liking a product. And this can be, you can say, not very much. Another can be, it is okay. Another can be, not very much. It is okay. Another can be, yes, we like. And another can be that we do not like, or these can be there. You can have 3, no problem at all. Another can be that profession. Your profession can be doctor, teacher, doctor. Okay, you can have doctor, and nurse, dentist, and you can have the therapist. All belong to the same profession. So therefore, your one variable should have only 2 levels. As I said, pass or fail or something like that. And another variable must have minimum 3 levels. You may have more than 3, no problem, but at least 3. Then another is the that the samples is selected randomly. The sample may be selected randomly, may or may not be. From the population. That means when you are selecting the sample, you may select the sample randomly, or you may not select the sample randomly. It's perfectly correct, nothing wrong in that. And then the sample is sufficiently large. That means it must be more than 30. Now, these are some of the assumptions which, if your data fulfills, then you can use the Cochran's Q test. Let us take one title. I am taking a study of effect of computerized spelling a study of comprised effect of computerized spelling training on spelling performance of, say, class 4th students of government schools of Delhi. Now here, you know, this comprised spelling training, this will have the 3 levels or more than 3 levels. Spelling performance will be whether the spelling is correct or the spelling is wrong. Now I can have objective something like this: to study the association between computerized spelling training and if you want to see English spelling performance, then you can write here English in that title. And computerized spelling training on English spelling performance. So therefore it is the association between computerized and performance of students. The hypothesis is that there is no significant association between okay. So let us now have our data. We go to the SPSS. This is my SPSS. So let us have the variable. Now here I will have the variable as I can call it the computerized training or training that I am having the 3 and one will be, let's say I have the surprise test and another can be I have the mock test and another can be I have the final test. And all these are computerized. Then I have the performance it has the 2 levels. One I will say pass and another I will say fail. Either you pass or you fail. So now we go to the, now here, and let us put the performance. Let us have 3, no problem at all. So we have entered the data and let us go. We go to analyze. We go to analyze, we go to non-parametric test. And then we go to K-related samples. Please note it down. We first go to the non-parametric and then we go to the K-related samples. And here you can say here is a Friedman, here is Kendall's, and this is Cochran Q. So you highlight the Cochran Q. So we don't want anything like that. Fine. So we have shifted all the variables on this side, and now we say okay. Just wait, let us See, this is something. Okay. Now here, so we had two levels of each variable. But in reality, it is given in the different book that you can have three. 3 by 2 can also be there. Anyway, so this is significant, this concurrence. Then Cochran Q is significant. That means there is an association between the exam result and the computerized testing. So you can have these two values. So let us use this. And here is so that was 4 point, I think it was 21.0. Let me see whether 21 or 22. It is 22. So it is 22, not 21. So the association between computerized spelling training, that training given and training not given. Between computerized training, association between computerized spelling training. And English spelling performance. Of students. Objective was to study the association between computerized spelling training and not on and English spelling. Because it is association, so it cannot be on. It has to be and. And it has to be and. Because the association between two variables. The data were analyzed with the help of Cochran's Q test and the so here computerized training here you say yes and then you say no, and then here it is performance, pass and fail. So this will be the performance let me write it here. This is performance. And this is your Cochran Q value. Now here it is 55, then it is 84, here it is 61, and then it is 32. And this value is 12.94, and it is significant at 0.01 level. So let us see the table heading. Cochran Q value of association between computerized training and performance between computerized training and English performance. This is the SPSS output. You can see the SPSS output. Are you able to see or not? You can see this was the further training, or you can say test, doesn't matter. Okay, there is a surprise test and there was a mock test. This was the one, and then another is, it is pass and fail. Performance is pass and fail. So that's what Ramanand, have you seen? Is it all right or not? Mr. Ramanand. Mr. Ramanand, have you seen the SPSA data, or you want to, still you want? So Indu, I showed you the output. computerized, and you can say spelling performance, English spelling performance of students. Now, from table 4 point, it can be seen that it can be seen then Cochran Q value is 12.94, which is significant at 0.01 level. So here I am putting the double star significant at 0.01 level. Mr. Ramanand, the 0.01 is your p-value. And when I say p-value, it means it is the level of significance, which may be 0.05 or 0.01 or maybe something else. It does not matter. Here I have not put. If you want, I can put one more column here, and then I can definitely write the, if you want, remark. I can say this is P is less than 0.01. So this is your p-value. But this p-value is nothing but level of significance. So if you are writing p-value, then you need not to put that double star. So either double star or this. Yes, Ramanand, it is the type of training. It's not yes or no, it's pass and fail. Yes or no, it's pass and fail. And the training is, you are right. It is the two levels which we wrote. It is surprised and mock. Yes. That's right. It is surprised, test, and mock test. That's right. Thank you very much. So here, that Cochran, so which is significant at this level. So it indicates that there is a significant association. There's significant association between the computerized training and English spelling of students. Thus, the null hypothesis that there is no significant association between computerized training and English spelling of student age rejected. Now DF is 1 because there are two, then we can write DF, no problem. It's significant this level with DF equal to 1. Now you can see that there are more students who passed when in the mock test. Because 55 and 61 is not a much difference, but there is a lot of difference between 84 and 32. So that means mock test helped in improving the English spelling. Further, more students passed when more students passed when they underwent mock training. Mock computerized training. So it may be said that mock computerized training, so it may be said that the computerized training helped in improving English spelling. And this becomes your computerized training helped in improving English spelling. So therefore, this is how you can do you can use the Cochran. Now, any question you want to ask, then I am going to the next statistical technique, and that is the phi coefficient. So any question you want to ask related to the Cochran? And if there is nothing, then I am going to the phi coefficient. It is more computerized training. Now in the phi coefficient, what do you mean by test conducted? Two tests. Yes, it is quite close to the McNamara. Now in the phi 1, there should be one variable having data on the nominal scale. And there must be two discontinuous variables each having two levels. McNamara is more powerful than Cochran. Discontinuous variable, each having two levels. So that means both the variables are dichotomous. Dichotomous means which are divided into the two parts. And let us have one. I'm saying the title is a study of truthfulness of scientists in relation to truthfulness of scientists in relation to politician. In relation to politician of India. Or you can say politician of Punjab or Haryana or anything, no problem at all. Of say Madhya Pradesh. And the objective is there is no significant association between truthfulness of scientists there is no significant objective. Oh my God. Objective is to study the association between truthfulness, to study the association between truthfulness of scientists and politicians. And the hypothesis is that there is no significant association between truthfulness of scientists and politicians. In hypothesis, you have to write the word association, because association is a technical word and relationship is a general word. So when you are formulating hypothesis, then you should not use the word relation. You should use the word either association or correlation. When you have data on the nominal scale, then you cannot use the word correlation. You have to use the word association. So let us go to our SPSS. And in the SPSS, let us have the data. So I have let's say, I say the truthfulness. So there are two levels. Number one is truthful. And number two is not truthful. And number two is politician. So politician also, the truthful or not truthful. Number one is a truthful, number two is not truthful. So let us have the data. You can copy and paste so that it is done fast. Okay, let us see now. You can, any variable you can write first. Jyoti, if you want, you can write politician first, or if you like, you can write truthfulness of scientist first. It does not make a difference. Any variable you can write first, and any variable you can write second. I have written survey. I have written the truthfulness of scientists. I have only written truthfulness. If you want to write full, you can write full. It does not make a difference. But when you are interpreting, at that time you have to write. Now we go to analyze. We go to analyze. We go to analyze, then we go to descriptive statistics. Please note it carefully. We first and click on analyze, then descriptive statistics, and then cross tab. And in the cross tab, there is a row and a column. You can shift any one you like. If I shift truthfulness in the row and politician in the column, perfectly correct. Then you go to the statistics. Here is a phi. So under nominal, there is a phi and Kramer's. So you is the same thing. Both will give you the same result, because in the package, it is the both. So you click it here and you continue and you say, okay. So this becomes your the value. That your phi value is this, which is not significant. So let us write so 5 coefficient is 0.04. And this is 0.04, and this is the p-value. So this is 66.4% error. So that means this phi value is not significant. And you can see the Kramer value is also the same. No, Jyoti, you have to practice, because it is a software. So you must know which statistical technique is given under which. You keep on practicing, you will understand. So this is the objective. And here it is 4.23.0 association between truthfulness of scientists and politicians. Truthfulness of scientists and politicians. So the 23 objective was to study the association between truthfulness of scientists and politicians. There were two levels of truthfulness. There were two levels of truthfulness, namely truthful and not truthful. The data were analyzed with the help of 5 coefficients and the results are given in table 4.23. Srinivas, if you want to learn about all features of the SPSS, then I can conduct a workshop. Otherwise, my book is coming, which explains everything. No, variable is not the scientist. It is the truthfulness of the scientist and truthfulness of the politician. It is not, scientist is not a variable. It is the truthfulness. It is the truthfulness of scientist and politician. please you say, first in this one you have written the truthfulness of the scientist, and the second is the truthfulness of the politician. And say here in the you see here in the row, I have given the truthfulness of the scientist, and in the column, I have given the truthfulness of the politician. So that is what we should remember. So this is the truthfulness of scientist, it is truthful, it is not truthful. And this is truthfulness of the politician. Truthful, and it is not truthful. So this is truthfulness of politician. And then here I am inserting one more, and that is phi coefficient. This is phi coefficient. And now here it is 38, it is 31, it is 25, and it is 24. And this is 0.04. So the phi coefficient of association between truthfulness of scientist and politician. Scientist and politician. So from table 4.23, it can be seen that the phi coefficient is phi coefficient 0.04, which is not significant. It indicates that there is no association between the truthfulness of scientist and politician. Between truthfulness of scientist and politician. Thus, the null hypothesis that there is a significant association between truthfulness of scientists and politicians is not rejected. It may be said that both scientists and politicians were found to be truthful to the same extent. So this becomes the finding, and this is how you have to write. By chance, if the phi value is significant, then you can say that there is a significant association, and then you can find out, okay, no in missing. Okay, that there is no. All right, thank you. Yes, here I wrote there is no significant association. So that's, thank you very much. So there is no significant association. So therefore, both seems to be truthful to the same extent. If there is some association, then you can say whether scientists are more truthful in comparison to the politicians. That you can find out from if you have the data of that type. So any question you want to ask before I say bye-bye to you? And now only one non-parametric statistic remains. If you want to read it beforehand, you can read. It is kappa coefficient. This is what we have to do, and this I will do tomorrow. Any question you want to ask before I say bye-bye to you? Though if there is an association, then the phi coefficient will be significant, and then you can find out in which case the number is more. Wherever it is more, then you say they are the more truthful, or if you have any other objective, it does not make a difference. Actually, you people should try to take the data, though you should take some data yourself and do it. Because everything, if I tell you, then it is something like a spoon feeding. And you people do not require the spoon feeding at all. Okay, so therefore my humble request to all of you is, please keep doing, take your own data, try to do analysis using SPSS and try to interpret it and see whether you are able to interpret or not. My book will be coming out, I think, within a month. It is on data analysis using SPSS. Okay, dear friends, then thank you very much. See you tomorrow. Tomorrow will be the last day of this particular webinar.